Okay, in this class we will discuss how DFT can be taken as a linear transform. We have defined the equation for DFT and IDFT. For DFT we have xk summation of xn e raised to power minus j 2 pi k n by n, which we have written as x of n wn to the power kn. Okay, where wn is defined as e raised to power minus j 2 pi by n. And similarly for IDFT. Okay, so for IDFT you have xn is equal to 1 by n summation of k from 0 to n minus 1 x of k e raised to power j 2 pi k n by n. Okay, or in terms of dual factor you can write it as x of n equal to k from 0 to n minus 1 x of k wn to the power minus kn. Okay, so this is IDFT, this is your DFT. Okay, so these are the samples of the Fourier transform. This is how you can recover the original signal from its samples. Okay, now this DFT, when you compute DFT, it can be computed using a matrix multiplication or a matrix transformation. And how we do that? Suppose in this equation you compute x0, the first sample from this equation. So k is 0 and is 0, so wn to the power kn, this factor will become 0. So as a result, your x0 is nothing but x0 plus x1 plus x2 up to x of n minus 1. Right? Similarly, for k is equal to 1, you will get the next sample x1. Now in this equation, your k is 1, and n will again start from 0 to n minus 1. Okay? So when n is 0, x0, you will get wn to the power kn. K and n both are, k is 1, n is 0, it is 0. Then plus x of 1, wn to the power kn. Now k is fixed to 1 and n is changing from 0 to n minus 1. Okay, so n is 1, k is 1, you will get wn. Then similarly x2, wn to the power 2, because for this term your k is 1 but n will become 2, so k into n will become 2, and last will be x of n minus 1 wn to the power n minus 1, because k is 1, n will become in the last term n minus 1, so it will become wn to the power n minus 1. Okay, similarly you can have x2. Now k is 2 and it will again repeat from 0 to n minus 1, so it will be first x0. In fact, with these terms we have wn to the power 0, but that is equal to 1, so I have not mentioned it here. Okay, in the first equation it is wn to the power 0, which is everyone. Similarly, in the first column it is wn to the power 0 multiplied with, but it is 1, I have not taken it. Okay, plus x1, you will get wn to the power 2 here now, because k is 2 and is 1. For this, k is 2 and is 2, will get wn to the power 4, and so on. Okay, and for this term you will get x of n minus 1 wn to the power k is 2, and last term is n minus 1, and so on. Similarly for x3, okay, it will be wn to the power 0 into x0 plus x1 w to the power 3 because k is now 3 and is 1. Then x2 w to the power, it will become k is 3 and is 2, it will become 6 and 9 and so on. This is equation number 4 and so on. Okay, so a set of equations basically. These equations can be written in the form of a matrix where on the right hand side you will have a column matrix of DFT samples, and on the right hand side you will have a product of two matrices. One will be n cross n matrix of two dual factors. One is n cross 1 matrix in which we have input samples x0, x1 up to x of n minus 1. Okay, so how is x0 obtained? It is the first row of this matrix multiplied with the column. So since x0, we have w to the power 0, w to the power 0 everywhere, it means the first row in this matrix is nothing but w to the power 0, w to the power 0 and so on. In the next row of this matrix, you have these coefficients. Okay, so you have wn to the power 0, then wn to the power 1, then 2, 3 up to wn to the power n minus 1. Then the next row will be wn to the power 0, then 2, then wn to the power 4, then 6 and so on. Similarly, wn to the power 0, wn to the power 3, then wn to the power 6, then wn to the power 9 and so on. Okay, and last will be your wn to the power 0. This will be wn to the power n minus 1 now. Okay, it will increasing 0, 1, 2, 3, last will be n minus 1 in the column wise. Okay, and the last element of this matrix will be wn to the power n minus 1 for row and n minus 1 for column. Both are n minus 1 into n minus 1. Okay, this is the transformation matrix. Okay, so if you write this matrix as wn and this column vector as small x n, multiply them to, you will get x of n. Okay, or in fact if you see in the vector theory or vectors, in the book, if you see, it is capital X, it is bold, in fact it is bold W, and it is bold small x. Wherever you get bold letters, they represent basically matrices. Okay, so this is the matrix column vector of the output, that is the samples. This W is the matrix of two dual factors, and this small x is the matrix of input samples. So if you multiply these two, you will get this matrix. This is how you can compute the DFT using the linear transformation. Okay, and similarly you can have equation for IDFT. Now see, what is the difference between DFT and IDFT? There is only a factor of 1 by n, and in place of wn to the power kn, it is wn to the power minus kn. It means since wn is a complex quantity, so minus kn means it is nothing but the conjugate. So xn, the IDFT, it can be written as 1 by n wn conjugate into capital Xn. Okay, this is how you can recover the original signals from its DFT. Okay, so you have to first find Wn, the matrix of two dual factors, then you have to find its conjugate. Okay, then multiply this with the DFT and divide each sample with n, you will get the original sequence Xn. Okay, so let us take one example. Suppose we have a input sequence Xn, which is equal to 0, 1, 2, 3, and you have to find its 4-point DFT. using linear transformation. Okay, so 4-point Dft means I have matrix is x4 is equal to w4 into x4. Okay, so x4 is a column vector of output x0, x1, x2, x3. Now w4 is a transformation matrix of two factors. It will be w4 to the power 0, w4 to the power 1, w4 to the power, sorry, it is in the first row, it is 0 everywhere. It is 0, all zeros. Okay, power is 0. Then w4 to the power 0, w4 to the power 1, w4 to the power 2, 3. Then 0, w4 to the power 2, 4, 6. Then 0, w4 to the power 3, w4 to the power 9. This is the matrix of total factors, and this is multiplied with the input sequence, that is 0, 1, 2, and 3. If you multiply these two, you will get the output, that is Dft. Okay, so first you have to find this matrix W4. So W4 is e raised to power minus j to pi by 4, which is e raised to power minus j to pi by, it is minus j pi by 2, and this is cos pi by 2 minus j sine pi by 2. So cos pi by 2 is 0, sine pi by 2 is 1, so it is minus j. Okay, it means if you see this matrix, you can take it here. Output is x0, x1, x2, x3, and this matrix, so w4 is minus j, so to the power 0, first row is 1, 1, 1, 1, and this is 0, 1, 2, 3. The second row elements, w4 to the power 0, it is 1, then to the power 1 it is minus j, then w4 to the power 2, so minus j square, it is equal to plus j square, and j square itself is minus 1, so it is minus 1. Then w4 to the power 3, you can take it as w4 square into w4. So w4 square is minus 1 into w4 minus j. So minus 1 into minus j, it is plus j. Okay, then it is again 1. Next rows, this we have done, this we have done. This is w4 square, again it is minus 1. w4 to the power 4, it is w4 square to the power whole square, it will become plus 1. Then w4 to the power 6, you can take it as w4 to the power 2 whole to the power 3. So it is minus 1. So to the power 3, it is again minus 1. Okay. Similarly, you can compute others. It is again 1, w4 to the power 3. Now as that is computed, it is here, which is j. Then w4 to the power 6 is w4 to the power 3 square. It is j square, that is minus 1. And then finally, this will become minus j. Okay. So if you multiply these two matrices now, so first row into first column, you will get 1 into 0, 1, plus 1 into 1, plus 1 into 2, plus 1 into 3. So these are added, 3 plus 2 plus 1 is 6. Then this into this, so 1 into 0, it is 0, plus minus j into 1, it is minus j, plus minus 2, plus 3j, second element. Okay. Similarly, in the third row, you have this multiplied with this column, so it is 0, minus 1, 1 into 2 plus 2 minus 1 into 3. The last is your 0. J into 1 is j. Then minus 1 into 2 it is minus 2 minus 3j. Okay, so you will get 6. It will become minus 2 plus 2j. It is minus 4 plus 2, it is minus 2, and it is minus 2 minus 2j. This is your DFT, 4-point DFT of this sequence using linear transformation. Okay, now what you have to do, you have to find the IDFT. This is a question for you. You have to find the IDFT of xk, which is this sequence using linear transformation. Now DFT is given to you. You have to find its inverse DFT. It means when you find IDFT of this, your answer should be this 0, 1, 2, 3. Okay, and for this you have to simply take the same concept. Xn is nothing but 1 by n wn to the power wn into x of n, and it is conjugate here. So you have to first find wn, that already have find it here, w4, take its conjugate, multiply with the DFT and divide each sample with n, you will get the input sequence. This you have to verify. Okay, you have to find the IDFT of this using this matrix transformation, and your answer should be this 1, 2, 0, 1, 2, 3. Okay.